Alright, in this video we want to talk about something called transformations, and transforming a graph basically means that you shift it around somehow. You can either move it, you can see the four types of transformations listed right here. You can either move it left or right, so you can take a graph and, let's say this is your parabola right here. By the way, this x squared function, that's what's called the parent function. It means the graph that all other parabolas look like. So I could take that purple function and I could do a couple things with it. I could move it right or left. So for example, that's an example of moving it right, that red graph right there. I could move it up or down. So I could take that purple and let's say move it down here. And in just a sec I'll show you how to do that. You could stretch or shrink it. So for example, this green graph right here would be like I shrunk it down, I kind of compressed it. And then I could reflect it over the axis. So that would be an example of that blue graph right there. Alright, so the way to remember, basically this purple function right here shows you what the parent function looks like. That's the purple graph right here, that basic parabola. And you could do these four things to the purple graph, like what you see right there in the red. So this number right here, the H number, and it tells you right down here, the H number tells us if the graph has been shifted left or right. And the way that you can remember is by this phrase right here, add to x, go left. So here's what I mean by that. If you took this right here and you added to x, you added 1, let's say, that would cause the graph to go left 1. Now you might say that's confusing. It seems like if I'm adding 1 to x, adding seems to indicate that we're going right. So why would that result in a graph moving left? And here's why. If you think of it this way, important things happen to a function when 0 gets plugged into it. So if you look at this arrow that I just drew towards x right there, the question is what x value would you have to plug in right there to make that parentheses equal 0? And the answer is x equals -1. So if you're on a graph and you're right here at 0, and then suddenly you move right there to x equals -1, which direction did you just go? And the answer is you just went left. You went left 1. So that's why adding to x causes you to go left, whereas if you were to subtract from x, if you were to do this instead, let's say I had y equals x minus 1 squared, that's going to cause the graph to go right 1. So it kind of works backwards to what you might expect. And then right here it says add to y, go high. So the difference between adding to x and adding to y, I'll show you with an example. Compare the blue graph over there, so where it says x plus 1, you can see the plus 1 is in parentheses, meaning this one right here. Compare that to this right here, and hopefully you can see the difference between that one in black and that one in blue. In this case, in the first case, the blue case, we're adding to x because the 1 is like almost attached to the x. It's inside the parentheses, and only after we've added to x do we then square it. On the other hand, with this graph right here, we first square the x and then we add 1. So it's like you're adding 1. When we say add to y, it means you're adding 1 to this function, to the function y equals x squared. So that's why we would say adding to y. So this is going to cause the graph to move up 1. So add to x means go left on the graph. Add to y means you're going to transform it, you're going to go high. Okay, so that, by the way, that number right there is the up-down control. This number right here tells you whether it's going right or left, and these are all listed right here. This number here, the A number, tells us if it's a vertical stretch or shrink. If A is bigger than 1, you're going to vertically stretch it, because if you multiply something by a number bigger than 1, that makes the number bigger. If A is less than 1, you're going to vertically shrink it. And then finally, if A is negative, it means you're going to reflect the graph over the x-axis. So that's like that blue picture right there. So this will become a little clearer when we see some examples. So let's do a couple of these right now. The goal with these problems right here is we want to simply tell, basically we want to tell what transformation has occurred, or in this case, what 4 transformations have occurred. So this g of x function right here, it takes the f of x function, meaning it takes this right here, the y equals, or I should say f of x, which is interchangeable with y. It takes f of x equals x squared, which is this function right here, and it does 4 things to it. And based on those rules that we just mentioned, see if you can pause the video and try to figure out what 4 things are done. So they're listed right here. You can either go up or down, left or right, stretch or shrink, and reflect. See if you can give the video a pause and try these, and then we'll go through them. All right, so let's take a look. So I'll tell you first of all that this right here, we said add to x, go left. We are adding to x right there, so that is going to make the graph go left 2. It's going to take this graph right here and it's going to shift it to the left 2. Okay, the next change will be this one right here. That's add to y, go high. We are adding to y, so we're going to go up 1 in that case. Okay, then this number right here, the 2, is either going to vertically stretch or shrink, and in this case, because it's 2, 2 is bigger than 1. So if you multiply something by 2, if you double it, it's going to vertically stretch it. By the way, when you vertically stretch something, that means that it horizontally gets smaller. It kind of compresses or shrinks. So whatever happens vertically, horizontally is the opposite thing will happen. And then finally, that negative right there is going to reflect it over the x-axis. And parabolas can only really ever be reflected over the x-axis. So here's what it would look like if you were to, let's say, compare these two right here. The blue one right there, and then the purple one right underneath. I want to show you the difference between reflecting over the x and the y. So this one right here, you're taking the y value. Y normally is equal to x squared in the parent function. You're taking the y value and you're making it negative. So you are reflecting over the x-axis. Why does that happen? Here's why. If you have let's say a graph right here, and that's a parabola, notice that where I am right now, the y's are positive, right? Y is positive above that line right there in the first and second quadrants. If I now take these positive y's and I suddenly make them negative, where does the graph go? And the answer is it gets reflected over the x, just like you see right there. Okay, why does that not work with this one right here? If you're taking a negative x and squaring it, here's why. Negative x squared is like negative x times negative x, and a negative times a negative is a positive. So in other words, if you look at this black graph right here, if you were to reflect this basically over the y-axis, it would look the exact same as before. So it doesn't really make sense to reflect the parabola over the y-axis. So right now I want to take this graph that we just did, and I'll show you piece by piece how that looks when you take the graph of x squared and start changing it around. So let's take a look at that. So first of all, you can see right here, hopefully that's you can see that picture all right. That red graph right there is the original function. That's the original function x squared. And this final one that I just highlighted right there, that's the ultimate result that we're looking for. So let's just go piece by piece. First of all, this one that I'm about to turn on, it says x plus 2. We said that add to x means you go left, so this should take that red graph and move it to the left 2. Let's see if it does. And you can see that blue one that just appeared has shifted it to the left 2. Okay, then that 2 in front, we're kind of building this up piece by piece, so we kind of work from the inside out to get a best picture. That 2, so that's this graph right here, should vertically stretch it by 2. So let's see the blue one get vertically stretched by 2. I'm going to delete that so we can see it better. Okay, and you can see the green one looks like, now you might say, well, how is that vertically stretched? It looks like it just got smaller. And it's true, but think about what direction it got smaller. It got smaller by being compressed horizontally. It's like you just kind of push that graph inward horizontally. Vertically, though, it did get stretched out. And here's the proof of that. If you look at this graph right here, let's say right there, when x equals 0 on the blue one, we're only at 4. But when x equals 0 on the green one, we're all the way up here at 8. So we've gotten vertically stretched out. It's stretched out from 4 to 8, and that makes sense because you're multiplying it by 2. So 4 times 2 is 8. Okay, so let's turn off the blue one. Now the green one to the next one that I'm about to turn on, the negative we said is supposed to reflect it over the x-axis. So let's see that. And you can see that orange one just got reflected. And then finally this plus 1 should take the orange one and bump it up 1. So let's see that, and there it is right there. You can see that it got moved up 1. So that's just a nice visual way to see how that works. Alright, let's take a look at this last one right here, the one that says number 4. So we want to again describe, looks like again there will be 4 transformations. And once again I encourage you to try to pause it and see if you can figure out what 4 things will happen here. So remember we said before add to x go left, we are subtracting from x right here, so that means going to go right 3. RT is just abbreviation for right. Okay, this right here is going to vertically, not stretch it, but this time it will vertically shrink it, and that's because you're multiplying by a number less than 1. That negative right there once again is going to reflect over the x-axis, and finally this plus 2 add to y go high, that means we're going to go up 2. And that's what the transform graph will look like.